Hi, welcome to another lesson at EDU Solutions Institute. Now, today we're looking at the CSEC chemistry syllabus, and we are continuing from last week's lesson where we looked at mole. Now, we looked at mole, calculating mole, and more specifically, mole in terms of volume of gases, and as well as using equations to show the link between mole ratio as well as to calculating unknown quantities based on given quantities from an equation. Now, this week's lesson, we're going to delve with some questions to utilize what we have learned in our previous lesson. So stay tuned as we explore these questions to get more from our mole concept. The first question here says, Jamal has 11.2 grams of potassium hydroxide and wants to know what mass of potassium sulfate he could produce if he reacts this with excess sulfuric acid, according to the following equation. Now, according to the equation, all right, and as we notice here, the equation is balanced. We have two K's on the left, we have two K's on the right. We have two O's here and four here, so that's 6 on the left, and 4 here and 2 over here, that's 6 on the right. And the H's, we have 2 and 2, that's 4. And over the right side, we have 2 times 2, which is also 4. All right, and then the S's, we have one S on the left, one S on the right. So we know this is a balanced chemical equation. And from this, without looking at the information given, we see here that for this reaction, to take part in full, we need 2 moles of potassium hydroxide to react with 1 mole of sulfuric acid to give 1 mole of potassium sulfate and 2 moles of water. All right, but as you know, when we do experiments, we don't necessarily use these same ratios. So hence, in this case, we use 11.2 grams of potassium hydroxide, which might not be equivalent to 2 moles. So the first thing here is to find how much moles of potassium hydroxide did Jamal actually use. So based on what we're given, we now know that the mole is equal to the mass over the molar mass. All right. Now the molar mass of potassium hydroxide would be that potassium hydroxide is KOH. The K, which would be 39, so it's 1 times 39, plus O, 1 times 16, plus H, which is 1 times 1. All right, so we have 1 O, 1 H, and 1 K. So in total, this is 39 plus 16 plus 1. This gives us 56. So it's 56 grams per mole. All right, so therefore we know that the moles now would be 11.2 over 56. And 11.2 divided by 56 gives us that instead of 2 moles, Jamal actually used 0.2 moles. All right, now the next part is what's the mole of potassium sulfate that would be produced? Now, potassium sulfate, right? So remember from our first normal equation, we would have used 2 KOH to give us 1 K2SO4. But instead of 2, we actually use 0.2. So therefore, we will not produce 1 K2SO4. We have to produce something else. So what we'll normally do is we show the relationship or the ratio of what we know to what we want to find. All right? So since we know that from the equation, it would have been 2 moles of KOH to give us 1 mole of K2SO4. But in this experiment, we use 0.2 moles of KOH, and we need to know how much mole of K2SO4 is produced. So from here, we do math. We multiply across, so it's 2 times X equals to 1 times 0.2. And hence we get that X is equal to 0.2 divided by 2, which we get 0.1 mole. So 0.1 mole of potassium sulfate was produced based on this reaction. All right, let's go. One more part of this question is, what's the mass of potassium sulfate that was produced? Now, we use the formula mole is equal to mass over molar mass. All right, so therefore, we find the molar mass of K2SO4. And K2SO4 is that it is 2 of K, which is 39, plus 1 times S, which is 32, plus 4 times O, which is 60. So from this, we will get 174 gram per mole. All right, so we know the mole, which is 0.1 equals to the mass, which we need to find, over 174. So therefore, mass is equal to 0.1 multiplied by 174, which is equal to 17.4. And the unit would be in grams. All right, so notice, very simple. Once we understand what's the purpose of the equation and what's the purpose of the formulas that we used in previous lessons. Let's look at the second question here that says, what mass of lead-2 chloride would be produced when a solution containing 0.3 moles of sodium chloride is mixed with a solution containing excess lead-2 nitrate? The equation is shown. And again, this equation is a balanced equation, so we don't have to balance it, right? But based on this, again, we would say that for the real equation, we would have used 1 mole of lead nitrate to react with 2 moles of sodium chloride, and that would have given us 1 mole of lead chloride and 2 moles of sodium nitrate. But in this case, instead of using 2 moles of sodium chloride, we actually use 0.3 moles. All right, so what we need to find is the mass of lead-2 chloride. So we're finding how much mass for that, right? Now that we know that we have this amount of moles of sodium chloride, we can equate sodium chloride to lead chloride, because that's what we need to find something for. So in the real equation, it would have been 2 sodium chloride to give us 1 lead chloride. But in this case, we use 0.3 sodium chloride. So we now equate it to X, because we need to know how much moles of lead is used. So again, it's 2 times X equals to 1 times 0.3. Divide by 2 on both sides. So the number of moles of PbCl2 would be 0.15 mole. All right, but that's not what we want. We want the mass of lead chloride. So therefore, we will now have to look into the molar mass, right? So we need to know what's the mass of lead. So the molar mass of PbCl2. And we go with it's 1 times the mass of lead, which is 207, plus it's 2 of Cl, which is 35.5. Okay? And that gives us And that gives us 278 gram per mole. And now that we know that, we can therefore find the mass, which is equal to the mole times the molar mass. Mole is 0.15 times 278. And hence we will get that it produces 41.7 grams of lead 2 chloride using 0.3 moles of sodium chloride. All right, so again, same step. We look from our equation, the link between what we know and what we need to know in terms of the mole. Then we look at what our actual mole is to find the mole of the unknown. Then we use that mole to find what we need to find. All right, so our next one, what volume of carbon dioxide at STP would be produced if 3.65 grams of magnesium hydrogen carbonate reacts with excess nitric acid as below. And again, this is a full balanced chemical equation that says that we needed 1 mole of magnesium hydrogen carbonate to react with 2 moles of nitric acid to give us 1 mole of magnesium nitrate, 2 moles of carbon dioxide, and 2 moles of water. All right, so we are given that we have the mass of magnesium hydrogen carbonate. So therefore, the first step is we need a molar mass of the MgHCO3 bracket 2. And that would be that it is 1 magnesium, which is 24, plus it's 2 hydrogen, which is 1, plus 2 carbon, which is 12, plus 2 times 3, that's 6 oxygen, which is 16. And therefore, that gives us, so it's 24 plus 2 plus 24 again, plus 6 times 16, which is 124 grams per mole. So now from this, we can find a mole of MgHCO3 bracket 2, which is the mass over the molar mass, which is equal to 3.65 over 124, which will give us 0.03 mole. All right, so now we know the mole of 1. We can now link it to the unknown of what we need to find. So we know that and what we need to find is for carbon dioxide volume. So it's for CO2. So from the equation, it was a 1, 2, 2. But in our experiment, or in the experiment that was done, it actually uses 0.03. We need to know how much it's produced here. So again, it's cross multiply, so it's 1 times x equals to 2 times 0.03. So therefore, the x would be 0.06 mole. But this question did not want us to find mole. It wants us to find volume of carbon dioxide, which would be equal to the mole times the volume at STP. Right? So it's the mole 0.06 times the volume at STP, which if we look up here, STP is 22.4 dm cube, or 22,400 cm cube. All right, so we're going to do it in dm cube, so that is 22.4, and hence we will get it's 1.34 dm cube of carbon dioxide that was produced in this specific reaction. All right, I'm going to skip this one because I'm going to ask you guys to do this one at the end. But before we do that, let's go to the last one here. All right, that says what mass of lead-3 hydroxide would be produced when a solution of sodium hydroxide containing 12.75 grams of hydrogen, the hydroxide ions, react with a solution containing excess Fe3 plus ions according to the equation given. All right, so this is an ionic equation. Even though we haven't reached there yet, it will be the same principle that apply. So we notice here that it was a 1 mole of the iron 3 ion, to give us 3 mole, which to react with 3 moles of the hydroxide to give us 1 mole of FeOH bracket 3. So we are given here the mass of the hydroxide ion. So therefore, the first thing is to find the molar mass of the hydroxide ion, which is it has 1 mole of oxygen, which is 16, plus 1 mole of hydrogen, which is 1. So therefore, this is a 17 gram per mole. So we can find a mole of the hydroxide ion, which is mass over molar mass, which is 12.75 divided by 17. And this gives us 0.75 mole. Right? And then, again, we will link what we know to what we don't know. So what we know is for the hydroxide ion, and what we need to find is the mass of the iron hydroxide, which is the FeOH bracket 3. And from the equation, it was a mole ratio of 3 to 1. But in actual reality, this experiment used 0.75 of OH, and we need to find for FeO3. So therefore, we cross multiply, that's 3 times x equals 1 times 0.75, and divide by 3. So therefore, the x would be 0.75 divided by 3. That gives us 0.25 moles of iron 3 hydroxide that was used. Now, the equation, we're still not finished because we need to know what is the mass of it, not the mole. So we know that mass again is equal to mole times molar mass. So therefore, we need to find the molar mass of FeOH bracket 3, which would be Fe has a mass number of 56, and it's 1 of it, plus 3 times oxygen, which is 16, plus 3 times hydrogen, which is 1. So therefore, that's 16 times 3 plus 56 plus 3, which is 107 gram per mole. All right, so therefore we can find the mass because we're multiplying this molar mass by 107 times 0.25, and this gives us a mass of 26.75 grams. All right, so now I'm just going to focus on this one here. I want you guys to try this and leave in the comment section what your answer for this question to be, because it says under the right condition, hydrogen reacts with oxygen as shown in the equation. What volume of oxygen would require to produce 960 centimeter cube of steam when it's reacted excess hydrogen both volumes being measured at RTP. And just for your information, at RTP, the volume value is 24,000 centimeter cube. And we're using this value because it's matching with the centimeter cube given in the question. All right, so I want you to go ahead, do this on your own, and put in the chat, put in the comment section of this video of what your answer will be, and I'll let you know if you're on the right track. All right, so thank you guys for watching. Hope you understand a little bit more on our mole concept, and I'll see you next week where we will look more in terms of what the mole is and how to calculate the mole under different conditions. Thank you, and I'll see you next week.